So problem 21. A certain company makes 12-volt car batteries. After many years of product testing, it knows that the battery life is normally distributed between 50 months and standard deviation 9 months, and the company doesn't want to make refund for more than 10% of its batteries. So what should be the point for which it offers the refunds? That means if we draw the diagram for battery life, then it's normal with mean 50 and standard deviation. So mu is 50. Sorry, mu is 50. Standard deviation sigma is 9. We are measuring in months. And if x is the point, little x is the point at which it says, okay, I'll make the guarantee for like X months. Then this much area should be 10%. That means if the battery life is smaller than X, that means it fails within little X months, then they will make a refund. For if it's more than that and then it fails, so for example, if it fails at this point, it will not make a refund. So like, I mean, I don't know how to explain this more, but smaller than X, the area should be 10%, as is drawn in the diagram, and bigger than X, obviously 90%. Now, our job is to find this value little x. Hence, I mean, this is one of those problems where we have to find the z-score for 10% and compute x from z. Usually we find z, like we have x, usually we have x, and from that we get z, and from that we get area to the left. But here it's the opposite. We have area to the left. For that we shall find z. From that z we shall find x. So let's look at the z table, and we search for 0.1. Alright, so I can see it. So it's 0.1003 and 0.0985. Sorry. So obviously 0.1 lies between these two. So 0.1 lies between 0.1003 and 0.0985. The z-score for this is minus 1.29, and for this is minus 1.28. Hence, our required z is the average of those two, minus 1.285. Now we know that x minus mu by sigma, that's like z. So obviously, which is minus 1.285. And in place of mu, let me write 50. In place of sigma, let me write 9. So this shall mean that x is minus 1.285 times 9 plus 50. which is 38.435 in months. So university would like to award top 7% of the students scholarship, and the scores are normally distributed between mean 650 and 735. Okay, so it's the same kind of problem. So it's normal with mean 650. And that means mu is 650, sigma is 35, and they want the point x for which bigger than x, that's like 7%. That means area left of x is 93%, that is 0.93. So we shall search for 0.93 in the z table. Okay, so 0.93 lies between this number and this number. We can clearly see that. And let's write it down. Point 0.93 lies between 0.9306 and 0.9292. The z-score for this is 1.48. The z-score for this is 1.47. So our required z is 1.475. So little x minus mu divided by sigma should be z, which should be 1.475, which means little x should be 35 times 1.475 plus 650, which is 701.625. Next problem. So height of 18-year-old men are approximately normal with mean 68 inches and standard deviation 3 inches. What's the probability that an 18-year-old man selected at random is bigger than 74 inches? Alright, so this is a extremely typical problem. X follows normal. We have done this problem several times. X follows normal with mean 68, standard deviation 3. We want probability x bigger than 74, which is 1 minus probability x less than 74. So straight up find the z-score. 74 minus 68 divided by 3, which is 2. And for 2, if you look up the z table, it shall be 0.9772. Hence, probability x bigger than 74 shall be 1 minus 0.9772, which is 0.0228. Next, okay, so now comes the interesting part. So there is a reason. I mean, in case you are wondering why they are giving such an easy problem, because we have done like 23, problem 23 was easy. It was an easy problem. So in case you are wondering why they give such an easy problem, it's just because of contrast. They are trying to show you like CLT versus a single normal. So let me write this down. So problem 23 was a single normal problem. Single normal. That is x follows normal dot dot dot. Problem 24 is a CLT problem. I mean, in the problem they are not saying it's CLT, but you have to apply CLT. So these are the kind of distinctions, I mean, you have to make in the exam. In the exam, the question will not tell you, okay, now start applying CLT. That's for you, that decision you have to make. And one word of caution is, when you guys were doing the homeworks, you were doing the homeworks for separate chapters. So for example, you are doing homework for chapter 6.1, 6.2, 6.3, and then chapter 6.5. So when you were doing 6.5, you knew that this will be CLT, so you started doing CLT. You did not have to distinguish between the two. Like, I mean, chapter 6.1, 6.2, 6.3, and 6.5 was not mixed together. When you were doing 6.2, and you were doing the problems, you knew that I have to do 6.2 here. So, but in the exam, all kinds of questions will be mixed. So from that mixture, you have to know that now this problem is from this chapter, this problem is from that chapter, like that. So how do I know question 24 is CLT? So once again here also, mu is 68, sigma is 3, that's it. But now they're asking what's the probability that the average height of a sample of 20. So that means there is an n here. Here n is 20. There are 20 people. And they are not asking the question, what's probability x less than 69? They're not asking that question. No, sir. They're asking the question, what's the probability x bar less than 69? This is a distinction you have to make. Okay, so let's get on with it. We know that to apply CLT, there should be like n bigger than equal to 30, or like the population is normal. Original population is normal. So is n bigger than equal to 30? That's not satisfied, but this thing is satisfied. So we can apply CLT, and CLT tells me that X bar follows normal with mean mu, that's like 68, and standard deviation sigma by square root of n. Sigma is 3, square root of n means square root of 20. So what shall be the z-score for 69? It shall be 69 minus 68 divided by 3 by square root of 20. I mean, you can calculate 3 by square root of 20 from beforehand, and that I think will be 0.6708, or you can keep it in this format as you wish. I mean, if this confuses you, if this thing confuses you, you can write down 69 minus 68 divided by 0.6708 as you wish, which equals 1.49. And now if you look up the z table for 1.49, you shall get 0.9319, and that's your answer. That's it, done. So 0.9319 is your answer, and you don't have to do 1 minus or anything because they are asking x bar less than 69. That means area to the left. So you have solved the CLT problem. That's it. Also, let me make this remark. Once you write this equation, the CLT equation, after that the whole problem becomes like an ordinary normal problem. Like, what I'm trying to say is, and I hope you will not be confused by this, what I'm trying to say is, if I just had a problem like if there was some kind of problem where some x used to follow normal with mean 68 and standard deviation 0.6708, and I told you to find probability x less than 69, then your calculations would be same and your answer would be 0.9319. So after you write the CLT equation, after you write this equation, the whole problem becomes an ordinary normal problem. Like, something follows normal, something comma something, you have to find area to the left or area to the right or area between two numbers, and that's all. I mean, yeah, that's it. That's all I wanted to say.